Hi students. So we are discussing questions from the chapter Chemical Equilibrium. Okay. So we have a good question in front of you. Can you read this question? All of you. Okay. So I will highlight the question for you. The question here is the equilibrium constant, okay, of some reactions, okay, are given as under. Okay, so they have given x to y, there is a reactant x and there is a product y. Okay, for this equilibrium reaction we have the equilibrium constant k as 10 power minus 1, and there is another reaction where y is getting converted to z and it is there in, you can see it's a reversible reaction, and for that the k value is given as 2 into 10 power minus 2, and the third one p getting to q and q getting to p, and for that k value is given as 3 into 10 power minus 4, and the next one r getting converted to s and s getting converted to r. For that the k value is given as 2 into 10 power minus 3. Okay, now the question here is the initial concentration of the reactants for each of the reaction was taken to be equal. So that means what is the initial amount that is taken here, x, let it be some x 1 mole per liter, that is same for y and p and r. So that means they are taking the initial concentration as same. Okay, now they are asking us to review the above reaction and indicate the reactions in which the reactants and products were of highest concentration. So they are asking you, out of these 4 reaction, in which particular reaction you have the reactant is present in larger amount, and in which of the following reactions the product is present in the highest amount or larger amount. We need to calculate that, or we need to find out that. Okay, so let's see how to approach this question. Okay, I hope all of you could see. Okay, now this is the same data that is mentioned here. I will take another color for you to understand little. So here the same data I have rewritten. Okay, x getting converted to y, k value is given here, y getting converted to z, for that also k value is mentioned, p getting converted to q, the k value is given, and r getting converted to z, the k value is mentioned. Now if we analyze these k values, we can understand that the k value is highest. The highest k value is in the case of which one? Actually in the first one. Okay, or I can say that the k value is highest for x getting converted to y. Okay, x getting converted to y. So what is the meaning of that? The k value is high means what does that mean actually? So I can easily say that, listen students, so I can easily say that k value actually means what? Actually k is nothing but the concentration of the product divided by concentration of the reactant. This is what we learned earlier. Okay, I hope you remember. Okay, yeah, let me rub this. Concentration always should be present in a square bracket. Okay, now listen, here the k value is high. K value high, if k value is high means what is the meaning of that? I can easily say the product concentration here is very high. The product concentration here is very high. I can say like that, correct? Okay, now why? Because k value high means this k, if the k should have a higher value, this is possible if the p should have a higher value. Okay, we know that the reactant concentration of the reactants in all the cases are same. So here p should be very high, then only we can say k value is very high. Also we are comparing the 4 and saying this. So we can say that the product concentration is higher in which reaction? When x is getting converted to y and y is getting converted to x. Now let's see in which of the following the k value is lowest. So when we are analyzing this, we can understand that in the third one where p is getting converted to q and q is getting converted back to p, the k value is the lowest, I can say, because it is 3 into 10 power minus 4. Correct? So now what is the impact of that? What does that mean? So that means k value is lowest means what, sir? What? You can understand k value is again nothing but concentration of the product divided by concentration of the reactant, correct? Concentration of the reactant. Now tell me, k value is lower, k value is lower, it means the product concentration is lower, or I can say the reactant concentration is the highest because they are inversely related. Okay, so they are inversely related. So I can say the reactant concentration in this case would be higher. So now you read the question again. They are saying review the above reaction. Okay, review the above reaction and indicate in which the reactant and product were of highest concentration. So I can say the reactant concentration is highest when the K value is lowest, that is for C. We can say it is for C, correct? It is for C only, the K value is lowest. Then the product concentration, we can see in which case the product concentration would be very higher when the K value is higher, that is when K is equal to 10 power minus 1, that is for A. So comparing these two, I can say option 2 would be my correct answer, C comma A. Clear? I hope it is clear for you. Okay. Yeah. Now many students may have a doubt like, sir, it is mentioned in the question like initial concentration of the reactants were equal. Please understand, it is the initial concentration. The reaction will proceed and we don't know at what time they are attaining equilibrium. At that point of equilibrium, we don't know its concentration, reactant concentration, we are not sure about it. That is what we are guessing from the K value. Okay. Yeah, I hope this question is clear for you. Any doubt? Yeah, based on simple K equation of the K, we can say if the K value is higher, that simply means the product concentration is higher or the reactant concentration is the lowest. If the K value is the lowest, that means the product concentration is lowest or the reactant concentration is the highest. Okay, now let's go to the next question. I hope you could see the question. Okay, now the question here is for the reaction. Okay, I can expand a little if needed. Okay. Yeah, okay, I hope you could see. Yeah, for the reaction carbon which is in solid form, now it is reacting with the carbon dioxide. It is reacting with the carbon dioxide. You are getting 2 mole of carbon monoxide which is in the gaseous form. This is also in the gaseous form, but this carbon is in the solid form. The partial pressure of carbon monoxide and carbon dioxide are given as 2 and 4 atmosphere. Okay, but for we know that gases have pressure, partial pressure, but carbon which is in solid form, it will not have this. Okay, this is the pressure value at equilibrium. Now they are asking you to calculate the Kp value for this particular reaction. Now we need to write the Kp value for this particular reaction. Okay, so as you see the reaction, you can see here, that is nothing but carbon in the solid form react with the carbon dioxide which is in the gaseous form, giving you 2 mole of carbon monoxide which is in gaseous nature. Now when you write the Kp, you know that in the equilibrium term, when you are writing in the terms of pressure or concentration, we ignore or we take the terms which are in solid as unity. So we can completely ignore the carbon which is in solid form. So Kp value would be what? The concentration, or we can say here the partial pressure of the carbon monoxide whole raised to 2, okay, divided by partial pressure of carbon dioxide. Okay, but all these values are at what? Don't forget that K is defined at equilibrium. So these are all values at what stage? At equilibrium. Okay, don't forget that it is a partial pressure at equilibrium. That is what they have mentioned in the question. So partial pressure of carbon monoxide is given as 2, so 2 square divided by partial pressure of carbon dioxide at equilibrium is 4, so 4 by 4 you will get a value that is 1. Clear? Easy question, direct question only. So I can say which is the correct answer for this one. Okay, you can expect questions like this. They just need to check whether you know how to write Kp in case when one of the reactant is a solid. Okay, so my answer is option 4. Okay, I hope it is clear for you. Now let's go to the next question. I hope you could see the question. This is a very important question you can expect. Okay, for which reaction we can say Kp is equal to Kc. Okay, so here for this question, if you want to answer it, you need to know the relation between Kp and Kc. Okay, so let's try to do this question. Okay, now we know that the fundamental relation between Kp and Kc is Kp is equal to Kc RT raised to delta Ng. Okay, here delta Ng is what, sir? Delta Ng is the difference in the number of moles of gaseous products of the reactants minus the number of moles of gaseous reactants. Okay, so what is it? I will explain it one more time. What is delta Ng? Delta Ng is nothing but difference. Okay, so what is that difference? I will write it down, then it would be clear for you. Okay, so don't forget this. This is very important. Okay, so I can say delta Ng is nothing but the sum of the number of moles of gaseous products, okay, minus sum of number of moles of gaseous, that is very important. So that's why I'm even writing this gaseous reactants. So don't consider non-gaseous things here while considering delta Ng. Okay, yeah. Now see here, I'm taking the equation 2NOCl, the first one 2NOCl giving you 2NO plus Cl2. So here you can see all are gaseous terms. Okay, now what you need to do, delta Ng is number of moles of the gaseous products. So 2, and here you can see 1. So 2 plus 1 minus here reactant 2. Okay, so 3 minus 2 you will get 1. So I can say that here delta Ng is 1 or its value is greater than 0. So whenever delta Ng has a value greater than 0, we learned that in that case, or if you see the equation itself, you can understand delta Ng is positive means the whole term would be positive, or I can say the whole term has a positive value in the numerator. So I can say in that case Kp would be greater than Kc. Kp would be greater than Kc. Now in the next case where you have the N2 plus 3H2 giving 2NH3. This is Haber's process. This is all are in gaseous terms. Here also delta Ng is number of moles of the gaseous product, which is 2 minus number of moles of the gaseous reactants, that is 1 plus 3, you can see here. So 2 minus 4 you will get a value minus 2. And you can see that here delta Ng is negative. Whenever delta Ng is negative, we can see that from the equation we can understand that Kp would be less than Kc. Okay. Now in the last case you can see here H2 plus Cl2 giving 2HCl. So delta Ng is equal to number of moles of the gaseous product minus number of moles of the gaseous reactant. So that is 1 plus 1, that is also 2, that is equal to 0. So that means whenever delta Ng is 0, so you can substitute here when delta Ng is equal to 0, what is happening? Kp will become equal to Kc. Clear? So tell me, sir, in which reaction Kp equal to Kc? I can easily say when delta Ng is equal to 0, that is happening in the equation 3. So option 3 would be my correct answer. Clear? Very easy, right? So I hope it is clear for you. Now let's go to the next important question. So the question here is, for the reaction CuSO4 5H2O, you can see here again this is in solid. This is solid, and that is giving you CuSO4 3H2O, that is also solid, giving 2 mole of water, which is water vapor or in gaseous form. Now they are asking which one is the correct representation. So they are asking you in terms of Kp or Kc, we can write it down. Okay, then we will see the options. So if you write it in terms of Kp, we can say that we can ignore this term and we can ignore this term. Why? Because both of them are in solids. So we need to consider only the partial pressure of water. So partial pressure of water, the coefficient is 2. So it will come like whole square. Correct? Now if you write it in terms of concentration, then also I can ignore the terms which are in solids. Okay, because its density is a constant value. So I can write concentration of water, the whole square. Correct? So and how you write Kp Kc equation? I can write Kp is equal to Kc RT raised to. What is the delta Ng here? Here I can say both are solid, you can ignore. So number of moles of the gaseous product is 2. There is no reactant. So I can say 2 minus 0, that is 2. Correct? So I can write Kp is equal to Kc RT the whole square. Correct? Now if you see the options, you can see all are correctly. Correct? So first thing in terms of Kp it is written, second one in terms of Kc, and the third one is a relation between Kp and Kc that is mentioned. So I can say option 4 would be my correct answer. Clear? It's very easy, right? So understanding this in the right sense is very, very important. Now we have the next question in front of you. Okay. Now the question here is, all of you go through the question. The question mentioned is, listen, for the equilibrium SO2 Cl2, which is in gaseous format, giving you SO2, that is a gas, and Cl2, that is a gas, what is the temperature at which Kp by Kc ratio is equal to 3? Now again we need to write down the relation between Kp and Kc. From that we need to identify what is the temperature at which Kp by Kc would be equal to how much? 3. Understood? So it's all of a mathematical nature. We can do that. Okay. So this is our equation. All of you could see it. Correct? SO2 Cl2, which is in gaseous format, and SO2, which is gas, and Cl2, which is also gas. So we need to consider all the reactants and all the products. So at equilibrium, they are saying the Kp by Kc value is equal to 3. Correct? Now we know that the relation between Kp and Kc is equal to Kp is equal to Kc RT raised to delta Ng. Correct? So here what is delta Ng, sir? Delta Ng is number of moles of the gaseous product, that is 1 plus 1, 2, minus number of moles of the gaseous reactant, that is minus 1. Correct? So 1 plus 1 minus 1, so you will get that as delta Ng is equal to 1. Now you can substitute that delta Ng is equal to 1 here. Correct? So the equation becomes Kp by Kc is equal to RT. We need to find out temperature. So Kp by Kc ratio is already given in the question as 3. So I am substituting that value 3, and R value we can say that it is 0.0821 when it is in atmosphere. Correct? Into temperature T. Correct? Now we can say that how to find T here? T is equal to 3 divided by 0.0821. So this can be written as 8.21 into 10 power minus 2. This is for making the calculation easier. So 10 power minus 2 will come in the numerator, and this will become 300 by 8.2. So you can even do it approximately, that is 300 by 8. How much it will become? 2, 4, this is 150. Okay, and this you can write it as 4 into 3, 12, 30, 4 into 7, 28. So somewhere around 37 Kelvin you will get the answer. Okay, if you do it approximately also. The actual answer is 36.54 Kelvin. So we will see whether that is present there in the option. Yeah, it is present. Okay, so I can say option 3 would be my correct answer. Any doubt? I hope it is clear for you. Okay. Yep, so you can practice all these questions. These are very important. And coming to the last question. So the question here is very, very important question for the day. So log Kp by Kc plus log Rt is equal to 0. Log Kp by Kc plus log Rt is equal to 0 is a true relationship for which of the following relation? Which of the following reaction? Okay, so I am expecting questions like this for this year. So you can you can just think about how to do this question. Okay, so first we need to, how to approach this question is, first we will write this equation clearly, that is log Kp by Kc plus log Rt is equal to 0. We know that we need to know little bit log A plus log B. What is log A plus log B? I can easily say log AB is defined as log A plus log B. Okay, so that means I can multiply these two, that is Kp by Kc into Rt. This is log A into B format. Okay, now what I can do, sir? When the log value will be 0, that is what next I am going to think. When the log of something will be equal to 0, we need to think like this: log of something is equal to 0. Log of something, we can say log of something is equal to 0. I can easily say when log 1, then it would be equal to 0. Okay, when log 1 it is equal to 0. Now tell me, sir, log 1 is equal to 0 means I can compare this 1 with this term Kp by Kc into Rt. So I can say Kp by Kc into Rt is equal to 1. Correct? Now how I can write? I can rearrange it and write it as Kc can be come to the right hand side. So Kc and Rt will come to the denominator. Okay, Rt will come to the denominator. Now I can say this can be written as Kp is equal to Kc Rt raised to minus 1. Correct? So now you think about the standard equation, Kp is equal to Kc Rt raised to delta Ng. So I can say that delta Ng is minus 1 here. Understood? So now check in the question options which one have delta and G is equal to -1. So I can see that 2SO2 plus O2 giving 2SO3. So here the number of moles of gaseous product is equal to 2. Okay, number of moles of gaseous product is equal to 2 minus number of moles of the gaseous reactant, 2 here, 1 here. So 2 plus 1, 3. So 2 minus 3 is -1. So I can say which one would be my correct answer, sir? Which one would be my correct answer? So you can see option 2 would be my correct answer. Clear? 2SO2 plus O2 giving 2SO3. 2SO2 plus O2 giving 2SO3 would be my correct answer. I hope until this it is clear for you. Okay.